Good morning, everybody. Today we will discuss about mass extinction. Now, the term extinction means demise or death of a taxon. Now, the fossil record it provides us a beautiful picture by which we can understand the history of life. That is how time after time new life form appears, and after certain time those life forms suffer death. That means those life forms completely wipe out from the earth history. Now, this demise of life forms or demise of any taxonomic level from the earth history is known to us as extinction. Now, there is a beautiful quote done by Leakey that death is a fact of life and extinction is a fact of evolution. So the term death it means individual, whereas extinction means that it is the end of an entire taxonomic group. That group may be species, that group may be genus, or any other taxonomic group. Now, extinction is a natural process. So there are many natural processes by which one species is not able to survive further. So whenever one taxonomic group is thought that they are not able to adapt with the changing environment, as we know that throughout the history of the earth it suffers many changes through time. So with this changing environment which happened in every geological age, in every geological period, if a taxonomic group was not able to survive or was not able to cope up with these changes, so extinction is disappearance of any taxonomic group or any evolutionary lineage, mainly due to the environmental changes. And due to these environmental changes, the taxonomic group they suffer narrow geographical range, that is their geographical area will be narrowed down, and as well as the stress of environmental change will force them to reduce their population size. So by this way a taxonomic group suffers extinction. Now, in terms of evolutionary study, extinction is immense extinction has immense importance. Now, due to the extinction, it basically removes the then population of the earth and thereby opens a new way for the new groups to appear in the earth and to radiate in the earth. So thereby extinction is the cause for demise of certain organisms, as well as it will also trigger to proliferate certain organisms. So thereby time after time the population structure of the earth is changed naturally. Now, according to Sepkoski, he tried to define the term mass extinction is any substantial increase in the amount of extinction suffered by more than one geographically widespread higher taxon during a relatively short interval of geological time resulting in at least temporary decline in their standing diversity. So, in the definition of Sepkoski, these two things are very important. The extinction should happen in geographically widespread area, that is, it should be global and in all ecological conditions, as well as the timing of extinction should be very short in terms of geological time. Now, extinction is a natural phenomenon we know, and it happens almost in every day, in every year. But the difference from extinction and mass extinction is, in mass extinction, a huge number of organisms will disappear from the earth scenario. So that is why the mass term is used here to indicate this vast demise of life forms from earth history. So extinction refers only the demise of a single taxonomic group, but in whenever we use the term mass extinction, it refers multiple taxonomic group wipe out or demise within a short interval of time. Now, how did we know that extinction happened? The extinction of a species occurs when the last individual of that species dies. So whenever we are going to say that the extinction of any species is happened, that means that all the individuals, including the last one, that also suffers death. That means they are completely erased out from the earth history. Similarly, the extinction of a genus happens when the last individual belonging to the last species within the genus that dies. So, have a important role not only to wipe out or to demise certain group of organisms from the earth history and appearance of new taxonomic groups, but also extinction take an important role in guiding the evolutionary path throughout the entire geological time. Now, the first study of extinction or mass extinction was done by Georges Cuvier. He is a famous French naturalist. He studied first about extinction. He found that mammoth, giant sloth, they become extinct during some ages in the Cenozoic time. After the study of George Cuvier, his student D'Orbigny, he he took the challenge, and he also studied and more concrete the idea of extinction. But it was in those early 18th or 19th century, people are not very much eager to know about extinction, or people mostly they neglected this kind of studies. And in the middle of the 20th century, sorry, in the middle of the 19th century, when Darwin and his co-workers, um, and also Charles Lyell, they provide us or they told us the evolutionary laws, the evolutionary phenomena, and they highlighted about the origin of species concept mainly. So thereby people mostly neglected the study of extinction. So Darwin's and co-workers, their study was in the 1850s to 1860s. In the early half of the 20th century, like in 1909, Chamberlain proposed that there are major phonal changes through time which provide the basis for stratigraphic correlation also. So these are used for biostratigraphic correlation, but till date, till the early half of 20th century, mass extinction is. But in the latter half of 20th century, about in 1950s or 1960s, the study of mass extinction taken by the scientific groups as an important event happened in the geological time, and that is an event which can shape the organic world time after time. So in 1950s or 1960s, people study the mass extinction happened at end Permian, that is about 240 million years ago. So this was the study from where the mass extinction study starts from a new angle. After the study of end Permian event in 1950s and 60s, around 1970s, exactly in 1967, Newells he overviewed the Phanerozoic extinction, pertinently entitled The Revolutions in the History of Life. So Newell in 1967 studied or documented all the extinctions happened during the entire Phanerozoic time, that is during the entire 540 million years time. And he proposed six major events happened in this Phanerozoic time in which life or majority of the life forms of the then earth was died out. The events are end Cambrian, end Ordovician, end Devonian, end Permian, end Triassic, and end Cretaceous. So these are the timings of those extinction events, and according to the name of the geological period, these are known as end Cambrian extinction, end Ordovician extinction, end Devonian extinction, end Permian extinction, end Triassic, and end Cretaceous extinction. Now, after the proposal of Newell, many research was going on to find out whether these are the only six or there are others also. In 1986, Sepkoski recognized that apart from those six, it is not only those six extinction proposed by Newell, but in the entire Phanerozoic time, there are about 27 extinctions of different intensity happened throughout the entire Phanerozoic times. So not only six, but including those six, there are together 27 extinction happened in the Phanerozoic. So it can be said that it is not the origination of species, but demise of species was also happened many times during the Phanerozoic time interval. Now, after the documentation of Sepkoski about the 27 numbers of extinction happened in the 540 million years time, people try to document it in a statistical way. And after various documentation, after various statistical work about the timing, about the extinction rate, and different things, people confirmed that it was not 6, it was not 27, but in the Phanerozoic time, there are 5 major episodes of extinction. That is, there are 5 major mass extinction events happened in the Phanerozoic time. So these fives are known as big five in nickname. And what are those big fives? These are happened in the end Ordovician, at end Devonian, end Permian or Permo-Triassic mass extinction, end Triassic, and end Cretaceous or Cretaceous tertiary mass extinction. So among them all mass extinctions, there are 27 mass extinctions happened in the entire uh, 540 million years ago, entire 540 million years time. But within these 27, these are the most renowned or most readily observed events, mass extinction events, which can be easily traced and which are far greater in intensity with respect to the others. So that is why these are known as, uh, among all the mass extinction, these are known as big five. Now, if you look at the extinction rate of these big five are famous because if you look at the species level mass extinction event happened during these times, you can see almost in all cases the extinction percentage of species is greater than 75%. In end Ordovician, it is about 85% species extinction happened. In end Devonian or late Devonian time, about 83%. End Permian, which is also called the mother of all extinction, that is about 95% of all species died out. In Triassic, 80%, and in the end Cretaceous, 76% of all species died out. And this is the time when the famous dinosaurs were also suffer extinction. In terms of generic level, you can see that about 50% of all genera were died out during these time intervals. And similarly, in the terms of family also. So about 15% to 20% at least of all families have died out during these time intervals. So you can see that during these big five mass extinction events, Earth was almost lifeless. A huge amount of life came to an halt during these time intervals. So that is why these are known as big five mass extinctions. Now, the extinction rate that is normal in the fossil record is known as background extinction. As I earlier said, and it happens in every day of life. So the day-to-day phenomenon of extinction of certain species is known as background extinction. And whenever the rate of this extinction happened during the background extinction time, that increased a much higher value. That means the extinction event is intensified in a much higher order. Then it is known as mass extinction. Background extinction rates are constant within clades but vary greatly between clades. So in almost in any taxonomic group, the background extinction rate is constant. So it is thought that a species after its appearance, it survives about 2 to 5 million years. So after every 2 to 5 million years, one species, one newly appeared species will suffer or extinction. So the average range of a species is thought to be about 2 to 5 million years. So you can see that within a taxonomic group, they have a constant rate. It can vary slightly, but almost they have a constant rate of extinction. The normal background rate of extinction is about 2 to 5 families of marine invertebrates and vertebrates per million year. So in every million year, there is about 2 to 5 families. That is a much higher taxonomic group. 2 to 5 families suffers extinction. And if you look at the species level extinction, it is about 1 to 10 species per year. So that is the background rate of extinction happened in almost every day of Earth history. Now, extinction events are relatively short in terms of geological time, and when the rate of this demise of species was greatly increased, greatly intensified within this short period of geological time, it is called mass extinction. And you can see that a mass extinction is about 60% of the total species present in that time. So it requires about greater than 60% species to demise, to suffer death within a very short interval of time, call it a mass extinction. And if you remember the previous slide, there we can see that in the all big five mass extinction events, the species percentage of extinction happened during those time intervals was much higher than the 60%. So the percentage on those big five was about 75 to 80% of extinction of species. Now, if you look at the sequence of events in a mass extinction, there are three events happen during the mass extinction. So at first, due to some perturbation of environmental conditions, here is huge rate of demise of species. So suddenly a threat appears to the living beings of the earth, and due to that many species are started dying out. So you can see the diversity drops certainly in a very high rate. So this is the drop in diversity. But among all the living organisms in that time, there are certain organisms who can survive these stressful situations, stressful environmental conditions. So they will survive the tremor. So this is the survival phase. And when the stress of the mass extinction completely gone, after the end of the tremor or after the end of the stresses, environmental stresses, and survive the tremor, they again start proliferation. That means they again radiate and occupy the vacant ecological niche provided them by the extinction event. So mainly three phases. In first phase, there is a huge rate of demise of species. Then this demise occur due to some environmental stressful conditions. Then there are some species who can sustain or who can survive this stressful condition. Those are the survival taxas. They will continue through time, and after the stress was completely over, then those survival taxa, they again starts to radiate and occupy the vacant ecological niche which happened due to the extinction event. So three phases. First one is extinction, second one is survival phase, and third one is recovery phase. So in extinction, demise of species, demise of organisms happened. Some remained, some are able to survive the stressful condition, that is they survived, that is the survival phase. And after that, those survival taxas, they again proliferate in the recovery phase, that is they recovered from the stressful situation and starts to increase their population, starts to increase their diversity so that they can uh, occupy the vacant ecological niche. Now, according to the mass extinction events and the different phases, and depending on the survival or continuation of the taxa in those three phases, that is the extinction phase, survival phase, and recovery phase, there are several taxas which are named differently. Now, in the first case, we may find that there are some taxonomic groups which are hard hit by the extinction event. That means which are not able to survive or which are not able to cope up with the stressful environmental conditions. So they became extinct in the extinction phase. So these taxa are known as extinct taxa. Now, the second one is known as holdover taxa, that is those taxa which are able to survive the extinction phase. That means in the extinction phase, somehow they are able to survive, but they are hardly affected by the extinction event, such that just crossing the extinction main extinction phase in the survival phase or just starting in the recovery phase, they are going to be extinct. So holdover taxa are those taxa which somehow survive the extinction phase, but in the survival phase or recovery phase, they are going to be extinct. So these are known as holdover taxa. The third type of taxa is known as progenitor taxa. These are the opportunist taxa, that is, they start their journey, they first originate during the extinction event when almost all other organisms they suffer extinction and the ecological niche becomes vacant. So during this vacant vacant playground, these taxas first originate and they will survive the survival phase and recovery phase, and they will starts to proliferate and form newer and newer forms in the recovery phase. So in an opportunistic way, when the ecological niche becomes vacant, these taxa first originate and they survive the tremors, they survive the survival phase, and in the recovery phase, they start proliferate. So these are known as progenitor taxa. The fourth one is the disaster taxa. These are again some kinds of opportunist taxa. So they take the opportunity of the vacant ecological niche and they appeared during the survival phase and they almost end in the survival phase or in the recovery phase, and they are not showing any kind of evolutionary branching or evolutionary proliferation. So these are almost a single species or a single taxonomic group came in the survival phase, and without any evolutionary change, that taxonomic group continues throughout the survival phase or just beginning in the recovery phase, and after that they will suffer extinction. The next group is known as survivor taxa. So these are the taxa which comes far beyond the extinction events. That is, they continue their journey, they survive the extinction phase, the survival phase, and although they are affected somehow in the extinction phase, but they survive, and in the recovery phase, they again starts proliferation. So these are known as survivor taxa. Next, the Elvis taxa. Here you can see that three taxonomic groups, this one, and this one, they are coming before the extinction event. Among these three, two becomes extinct. So these are the extinct taxa. Two becomes extinct in the extinction event. One survives the extinction events, and in the recovery phase, from this survive taxa, it proliferates and form newer taxonomic group or newer taxonomic species or genus which looks similar or which are morphologically similar to these previously known extinct taxa. So these two, if I name them as, say for example, B and C, and these two as X and Y, so these B and C, say for example, came from A. So A, X and Y starts their journey before extinction. X and Y extinct in the extinction phase. A continues, it survives the extinction phenomena. In the recovery phase, from this A, new taxonomic group appear, that is B and C, and this B and C, they look similar to XY, but phylogenetically, these B and C are completely different from XY, but BC looks like XY. So as B and C looks like XY, it is thought that this B and C occupy the ecological niche, the same ecological condition of X and Y. So as their lifestyle is about same like X and Y, so that is why they looks almost similar. These two taxa are known as Elvis taxa. The last type of taxa is known as Lazarus taxa. Here the taxa came far before from the extinction event. In the extinction event, they are hardly hit and hardly affected, and in the survival phase, it was found that there was no presence or no trace of these taxas. But again, in the recovery phase, we found the evidences of their presence. So this indicates that these taxas in the extinction event, they are hard hit and they hardly reduced their number, their taxonomic um, number, as well as the numbers of individuals. So that is why in fossil record we did not get their evidences. But whenever the stressful situation is over, then again they starts to increase their individual number as well as the taxonomic numbers. So again in the recovery phase, we are able to find their presence in the fossil record. So these kinds of appearance of a near demise of certain taxas, that means these taxas looks like they became extinct in this extinction event, but in the younger geological time it was found that they again reappear. This kind of taxa is known as Lazarus taxa, and the effect is known as Lazarus effect. So Lazarus taxa shown Lazarus effect, and in the recovery phase they again starts appear, that means the record is again found in the rock record. So these are the different kinds of taxa according to their nature of extinction and survival and evolutionary proliferation during the entire extinction events. So these are the definitions of holdover taxa: belonging to a higher taxon that experiences significant level of loss in the mass extinction. They survive the extinction interval only to become extinct in the survival or recovery phase. Disaster taxa: the opportunistic species whose presence is a sure sign of elevated environmental stresses. That means they appear during the extinction event when the present organisms in that time they find a stressful situation to survive, but within that stressful situation these taxa are opportunistically appeared and occupy the vacant ecological niche. Projected taxa fast evolved during the mass extinction interval, survived the mass extinction event, and dominant groups become dominant groups during the recovery phase. So in the recovery phase, they starts to diversify again. Lazarus taxa vanish from the stratigraphic record during a mass extinction event, are not present during part or most of the recovery, and then again reappear in the record. Elvis taxa show the same temporal pattern of Lazarus taxa, but are only convergent with rather than taxonomically the same. So these are almost look same, but they are not taxonomically of same groups, but they look morphologically similar to the pre-extinction taxa. Now, if we look at the tempo of extinction, we find that there are different tempo of extinction happen. There are certain extinction event in which we can find out that all the taxas they suddenly appeared within a short period of time, and they looks like this kind of straight boundaries up to which this pre-extinction taxa survives. And suddenly, at this time interval, all these taxas died out, and after that, new taxa reappeared. So this almost looks like a single boundary which separates the pre-extinction and post-extinction uh, taxa. So that type of extinction is known as catastrophic extinction. It lasts about 1 to 1,000 years. So geologically, 1,000 years is almost a blink of an eye. Next is the stepwise extinction. Here you can see the extinction time is much larger than the catastrophic event, and here there are different steps like manner by which all the pre-extinction taxa they suffered extinction at different time intervals. So although this entire event is known as a single extinction, but it happens in different stepwise patterns. So that is why it is known as stepwise extinction. So it is not a single catastrophic boundary. Instead, there are multiple shots in which the taxonomic groups suffers extinction. And the last one is a gradual extinction where you can see that there is no catastrophic um, type, no stepwise pattern, but within a certain period of time, species or taxonomic groups gradually different taxonomic groups gradually decline, different taxonomic groups gradually died out. So this is known as gradual extinction. It lasts about zero point 0.5 million years time. So it happens for a much prolonged time compared to the catastrophic and stepwise extinction events. So these are the three types of extinction phenomena observed depending on their suddenness or depending on their uh, timing of extinction event happened in the geological time scale. Now coming to the causes of extinction, it was thought that there are multiple causes maybe there for all those mass extinction to be happened throughout the entire geological time. The first one was thought to be the bolide impact or asteroid impact, that any extraterrestrial body from the universe they impact they came to the earth and impact the earth's surface, and thereby the entire earth was covered by the impact dust particles, and it discarded all the sunlight, so the entire ecological condition, entire environmental condition becomes stressful. And the evidences for the bolide impact was the iridium anomalies, that is the chemical element which is not found in abundant quantity in the earth crustal condition, but it was found that there are certain intervals within the earth history during which the concentration of iridium in the crustal rocks becomes extensively high, and all the meteorites they have the high concentration of iridium. So it was thought that it was the meteorite which uh, when collide with earth, which impact on the earth, results the increased percentage of iridium to disperse throughout the earth surface, throughout the earth crust, which ultimately goes into the rock record and thereby increase the normal iridium concentration during those time intervals. Apart from that, due to the meteorite impact, the quartz grain found in the earth crust, they becomes highly pressurized. So their nature, their microscopic properties become slightly changed. So those are known as shocked quartz. Apart from that, microtektites and glass firules are also found to be evidence of bolide impact or meteorite impact. Second cause is the volcanism. The eruption of vast provinces or vast amount of volcanic material is thought to be one of the uh, important cause, one of the main cause for extinction. Now, during volcanism, along with the molten material, along with the lava, some gaseous material and the toxic aerosols, they came out from the volcanic mouth, and they easily dispersed in the upper atmosphere. So these volcanic dust and volcanic toxic gases, they also are able to discard the sunlight and the environmental condition at the atmosphere and all the other environmental conditions, the soil, they become suddenly toxic. So that also brings the environmental condition in a stressful situation in which the organisms are not able to cope up. So volcanism, intense volcanism or prolonged volcanism or vast amount of volcanism may also cause for extinction. The third cause thought is the regression, that is the lowering of sea level. So due to the lowering of sea level, vast shallow marine areas are now exposed. That means those vast shallow marine areas are now become land. So all the shallow uh, marine organisms, they are not able with the sudden regression event, and the entire marine scenario, the entire marine environment, physico-chemical conditions was changed. So thereby, due to the regression, marine organisms are hard hit, and uh, they will suffer extinction. The fourth cause thought is the anoxia and transgression. Now, the opposite of regression is transgression. So, due to transgression, the sea level will change. So, more and more land area was now inundated with marine water. Now, due to the sudden increase in water level, the coastal areas, all the organisms, all the plants of the coastal areas, they are suddenly now submerged within the water. So in this submerged condition, they starts degrade, and the present shallow sea is becomes highly deficient in oxygen. That means anoxic condition comes into the scenario, and in this anoxic condition is not good or not uh, helpful for organisms to survive in those conditions. In the other way, the shallow sea organisms which was previously there before the transgression event, those are now suddenly having a higher water depth because of the increased sea level, because of this transgression event. So due to that, those organisms are also not able to cope up with this increased amount of water pressure, that is increased amount of bathymetric pressure. So they also were not able to cope up with this changing sea level. That means due to this, they all those shallow level organisms as well as the coastal organisms, coastal plants, they also suffer extinction. And the third one is the climate change. So this climate change indicates either cooling or warming. Now, either cooling or warming, they involved the most of the mass extinction events uh, happened in the entire life. Now, what happened in the climate change mainly due to warming and cooling? Due to warming or cooling, the latitudinal temperature areas, the latitudinal temperature bands, they are shifted. So, if say for example, if it is global cooling, so if cooling happens globally, then the polar cold region extends the latitudinal uh, boundary far more towards the equatorward. That means the cold condition was extended far equatorward. So the tropical hot humid conditions are now become restricted to a very narrow band. If global cooling was more intense, then it was found that the entire earth becomes almost like a white ball. That means all the areas of the earth, including the equatorial region, that also becomes frozen. So the tropical or equatorial floras and faunas, they suffer a very cold, chilling conditions. So these faunas, these able to cope up with these cold, chilling atmospheric condition, cold, chilling weather. So they will suffer extinction. Similarly, if there is global warming, then the equatorial, tropical, hot, humid region will extend far polwards. So the polar faunas, polar floras, which are previously in the cold condition, they will now suffer a more hot, humid situation. And in this changing climatic condition, the polar faunas, they are also not able to cope up. So due to the climatic changes, whether it is global cooling or whether it is global warming, basically the ecological temperature boundaries that will shifted either poleward or equatorward. So the ecological condition for the faunas living in one latitudinal condition, that becomes narrow down. That means the geographical area of organisms becomes very narrow, and ultimately that will force them to suffer extinction. Now if we look at the big five mass extinction into slight details, the first or the oldest mass extinction happened in the Paleozoic time, that is the end Ordovician mass extinction. It is the earliest or the oldest of the big five, happened about 439 million years ago. The life forms of this time was hard heated. Plants, insects, tetrapods had not yet developed during this time, so they are not affected. But the marine organisms, they were hardly affected, particularly the brachiopods, graptolites, echinoderms, trilobites, cephalopods, corals. They are hard heated and becomes extinct in this time interval. The suggested causes for extinction in the end Ordovician time: the climate change, drop in sea level, that is regression, asteroid or comet impacts, that is bolide impact or meteorite impact. So you can see that there are multiple causes which are responsible for extinction to be happened in the end Ordovician time. The second major mass extinction is known as the late Devonian extinction, happened about 365 million years ago. Insects and tetrapods yet to be developed, yet to come in the Earth scenario. But plants, particularly the rhinophytes, they are hard-hit and thereby decreased in number. Marine organisms like ammonoids, brachiopods, corals, the fishes, agnathan fishes, these are the fast jaw fishes, placoderm fishes, ostracods, trilobites, all these marine organisms are again hard-hit. So the organisms which survived the end Ordovician extinction, they proliferated after the end Ordovician time, and again in the late Devonian time, they are again hard hit by the late Devonian mass extinction event. Again, the causes are multiple: climate change and multiple number of asteroid impact events are there in the late Devonian time, which ultimately cause or which ultimately results the mass extinction to be happen. Next, the end Permian mass extinction, it is also known as the mother of all mass extinction, happened about 245 million years ago. About or greater than 95% of all species suffers extinction. So Earth becomes almost lifeless. Plants, among the plants, the dominant glossopteris, that is the coal bearing plants, coal formational plants, they suffer extinction. Among insects, two-thirds of the insect families become extinct, and six insect orders. So look at the taxonomic level. Six insect orders they disappeared. Tetrapods, amphibians, and mammal-like reptiles, they are hardly affected. Among marine organisms, the benthic foraminifera, brachiopods, bryozoa, echinoderms, 44% of all fish families, all graptolites. So in this time, all graptolites, all solitary corals, and all trilobites are completely erased out from the earth history. So this end Permian extinction is the cause for complete demise of these organisms, these faunas, graptolites, solitary corals, and trilobites. Suggested cause for impermian: there was major climate change happened during that time. Regression was also there. Massive carbon dioxide input was found to occur during that time. So the atmosphere becomes highly carbon dioxide rich. Ocean anoxia was also there. Asteroid impact happened, and high volcanic activity is also there, which is corresponding to the plate tectonic activity and the fragmentation of the supercontinent Pangea. So due to the again the multiple causes are involved for the end Permian extinction. That is, together these causes are responsible so that the earth becomes almost lifeless. Among all the species, only 5%, it was only 5% who are able to survive this tremor. Next, the end Triassic mass extinction event. It is the fourth among the big five, happened about 210 million years ago. Several orders of gymnosperms were lost, and the dichroidium flora became extinct. Insects were not affected severely during this extinction event. Among tetrapods, some reptile lineages, mammal-like reptiles, the therapsids, they especially wipe out from the earth history. Marine organisms, ammonites, bivalves, brachiopods, corals, gastropods, sponges, they all hardly affected in this extinction event. Suggested causes for this event: asteroid or meteorite impact, climate change, and volcanic activity. So again, multiple causes are there. And the last among the big five of mass extinction is known as the end Cretaceous mass extinction, or Cretaceous tertiary mass extinction, or it is known as KT boundary mass extinction, or in the present day it is known as, apart from KT, it is known as KPG. So K stands for Cretaceous and PG stands for Paleogene. Previously it was known as KT. K stands for Cretaceous and T stands for Tertiary. But if you look at the geological um, level of geological age, this Cretaceous and Tertiary are not matched. So that is why in present day it was known as Cretaceous and Paleogene. So these are of same level of geological time. So nowadays it is known as KPG extinction also. It happens about the 65 million years ago. About 75% of plant species extinct. Insects not affected severely. Among tetrapods, 36 families from three groups extinct. All the dinosaurs of different types, they suffer extinction. Along with the dinosaurs, the plesiosaurs, pterosaurs, they also suffer extinction. Marine organisms, ammonites, completely demise, complete extinction of ammonites. Cephalopods, other cephalopods also, bivalves, foraminifera, ichthyosaurs, this is a marine reptile, mosasaur, another marine reptile, planktons, and rudist bivalves. So these all marine organisms are again hard hit, and two main organic groups, one in land, that is the dinosaurs, and the other in ocean, that is the Ammonites. They are completely wiped out from the earth history. Suggested cause, the famous cause proposed by the Alvarez peoples, the senior Alvarez and junior Alvarez, father and son. They proposed the cause for mass extinction is the famous asteroid impact happened during that time, and the impact crater for the asteroid impact in this time was found near Mexico, that is the famous Chicxulub crater. Apart from that, during this time interval, the famous Deccan Trap eruption also happened, and the eruption was so vast that it can be a sole cause for extinction to be happened. So together, asteroid impact happened, a huge, vast um, size asteroid hit the Earth, as well as a vast amount of volcanic activity, that is the Deccan Trap eruption, happened for a prolonged amount of time in several phases, which ultimately results for climate change. So again, multiple causes are involved there for the end Cretaceous mass extinction event. Now, in the recent day also, in the present time where we the human belongs, that in that time we are also going through an extinction event, and this time the extinction is done by a single biological species, that is Homo sapiens. So he at this time, if it we consider it the or many scientists consider it as the sixth major mass extinction event, and if you look at the cause of this, all previous big five mass extinction happens occurred in the geological past, and the present day mass extinction happen is which is going on. If you look at the causes, all the previous mass extinction events, the causes are entirely natural. So any organism group living at that time, they did not have any control on those causes. Whereas in the present time, in this sixth mass extinction which is going on, in this time, the probable cause is the human themselves. So human impacts on the nature, on the environment, is thought to be the sole cause for many organism groups to suffer extinction. Now, there are two phases a thought to be going on in this extinction event. First phase begins with the dispersal of modern humans. So when the modern human beings, when the modern Homo sapiens, they dispersed in different areas of the earth and they encroach in different lands, in different environmental conditions of the earth. And it was found that starting from this dispersal of human beings over the different places of the earth, many organisms of the earth, their diversity or their numbers were hugely dropped. Say, for example, these rhinos, kangaroos, mammoths, ostrich in different continental areas. You can see the continental areas: Africa, Australia, North America, Madagascar, New Zealand. So, in all other, in almost every continental areas where human encroach was happened, the native organisms of those places, of those continents, they suffer threat due to different behavioral impact of Homo sapiens. The second phase of present day extinction was thought when a agriculture revolution happened at about 150 to 200 years ago, when the industrial revolutions happened and many new and new uh, tools are used in the agriculture purpose, and we use many insecticides to for growth of the crops and thereby kill the pest, and thereby we are basically damaging the natural habitat of the different pests of different insects, and to increase the population size, or to manage the population size of the Homo sapiens, we are day after day we are encroaching to new habitable areas. We destroy the existing habitat areas such as the forest, such as the waterlands, shallow ponds. These are destroyed by humans to manage the increasing human population, and all we also uh, go for over exploitation, increase use, and no proper scientific method of sustainable use of things. So thereby we invade to newer and newer ecological condition, newer and newer habitat, and we destroy those habitat areas, and thereby we become the cause for disappearance of those taxonomic groups. And many groups are not at all known to human civilization also. So this habit of Homo sapiens is seemingly increased in the past centuries, and at this time it was the first time in the entire earth history when the mass extinction is going on due to the behavior, due to unscientific behavior of a single biological entity, that is the Homo sapiens. And the thing is that if you look at all other previous extinction event, after the extinction events, some species are able to survive, some taxonomic groups are able to survive, and in the recovery phase, only the survival phase are start proliferation. And this recovery phase or this proliferation of organisms comes when cause of those extinction event to occur is completely gone. So until the cause of the event for all the previous mass extinction events was not completely gone, there was no recovery of organisms. Now, if you consider the same phenomena for the present day mass extinction event, here Homo sapiens, that is the biological species responsible for the present mass extinction. So, if the biodiversity or the biotic world has to recover from this mass extinction event, then the cause of the event must dissipated. That means the human have to dissipated, human have to wipe out from the earth history. So what we did consciously or unconsciously, by knowingly or not knowing it, we are digging our own graveyard. So if we did not change our habit, if we did not change our daily practice, and still continuing to modify the environment, then it will come at some day when the cause for the extinction of the other organisms, that is the humans, the Homo sapiens, they will simply demise from the earth history. So that's all. Hope you will understand, and hope this lecture will encourage you to maintain the ecological conditions, and it will prevent you to hamper or to hamper the environment. So maintain the environmental balance, maintain the ecological balance. So not only the humans, not only the Homo sapiens, but along with us, the other organisms can also live happily. Thank you.